All right, we are still in Unit 1 in AP Stat, but we are talking about skewness now. We just were working on measures of center, but now we're hitting on the idea of skewness again. We kind of, like I said, these videos are kind of encompassing all of Unit 1 in AP Stat. We're picking apart certain things, but they spiral and they build. So we've been talking about frequency tables, but we've been talking about them in each videos, in each section up to this point. And now we're talking about skewness again, but we're hitting it home in terms of how it works with center. So again, I'm reiterating to this is the normal curve, right? This is that normal bell-shaped curve that we're going to be talking about for a majority of this class. And skew, when you're viewing the idea of skew, it's like a lean in your graph. It's leaning one way or another, basically is what we're saying. This example, we should already know what it is. It's skewed to the right because it's thinner to the right. Now, because it is skewed to the right, this idea underneath it is what I want you to see. Because these are things that will pop up. Roughly where things are. Now, you see where this peak is? That should make sense. That's the most common item. That's why the mode is right there at its highest peak. The median is roughly the middle of your data, where a majority of your middle should end up being. But the reason why the mean is way out here is you're going to have outliers that pull it. Remember, an outlier way out here, like maybe someone who makes $1 million, is going to pull that mean down farther. So that's why your mean, when it's skewed right, is a little farther down, right? And then the mode is normally where your peak is because it's the most common item with the median falling in the middle. It's where the tail is, right? It's the tail is to the right. It's why it's skewed to the right. The tail is where the outlier is going to be, whereas now everything is skewed to the left. And again, now there's an extremely low value that's pulling everything down, which is why the mean gets pulled down, because that outlier that's way down there is dragging everything down. This is still the most common because it has the highest peak there, and the median, all right, is always falling right in between them in the middle. It's skewed left, same idea, the tail's to the left where the outliers would be. All right. Now, let's use the calculator to find the mean, median, and mode of them just so we can see them. If you press stat, all right, I'm going through this, so make sure you guys have your calculators out. And again, pause the video if it's moving too fast for you. But the idea here is you press your stat button on your calculator, and you press edit on the calculator. I want you to plug these values in for me. All right, so plug these values in. I made them up. They're not coming from anywhere other than me making them up. So plug those values in. All right, there they are again. Now, notice I have data in my set already, me personally. This was the old data that I was using. So what I'm going to go over here is how do I get rid of it if there's data in the data set. And this is key. You got to clear it all out. Now, it doesn't seem very key to you, but what I'm asking you to do is to scroll up to L1. And here's why I'm doing this. This is huge. You're going to mess up your calculator if you are not listening to me when we're doing this. So hopefully you're paying attention. Go up to L1. You highlight L1, right? Press clear and enter and it all goes away. If you press delete, that sucker's going away. Do not press delete. If you do, it deletes the whole L1. You do not have an L1 anymore. It is gone. You're going to have to somehow restore to factory settings in order to fix your issue. You clear it. You're not deleting the column, you're clearing the column, all right? Clear and enter. Now I want you to plug those values in instead into your L1. So take a minute, plug those values in, and when you do, it should look like this, okay? You press second and mode, again, that takes you back to the main screen, clears you out. So then once you're back at the beginning, press stat and arrow over to highlight calc. So press stat, arrow over to highlight calc. We want one variable stats because we are only looking at one column of statistics. So we want one variable stats. You press enter. And when you do, all right, this is what shows up on my screen. I want what's in list 1. You could have it in list 2, list 3, all right? Frequency list, all right, is all we're talking about. Scroll down to calculate and just press enter. It literally is giving you all the stats. I don't have to sit there and find the mean by hand. And the beautiful part of statistics is you can use your calculator in everything. Every aspect, there is no part of this exam that you are not allowed to use a calculator on. So you just found the mean, the median, the mode. You found it all. It's all right here for you. This gives everything. This gives you sample mean, Standard deviation, when we get to that, it gives you the lowest value, gives you the highest value. Eventually, when we get to box and whisker plots, it gives you the first quartile, the third quartile, the median. You got it all. All of it. It's all right there. This course can and will be done on the calculator. You need a calculator. You don't need to borrow one from me. You need a calculator of your own at home in order to do this. All right? We can try to loan out whatever we can. We have calculators in class, but you need your own when it's all said and done. So, let's work on variation, which is the next topic. All right? Variation means how does our data vary from the whole? All right? Variation calculates how the data is spread apart. Okay, how is our data spread all over the place? Some kids wonder why we need to know how data is spread out. It's a simple question. Why is it important? Kids say we have the mean, which is an average. We now have the median. All right, that's like your middle of the data set. Why do we need to know the spread of our data? All right, well, let's say you go into a bank to get some money out. All right, or you go in, you make a deposit, or you just want to cash a check, whatever it is. Right? You go into a bank, you got some money out, you want to deposit, whatever it happens to be. Sometimes those lines are long, very long, and they're overrun by some horrible elderly people who have no idea what's going on in this world. So, point is, haven't you wondered, is there a better way? Right? I don't want to wait in this long line. Well, we're getting farther along with technology that for the most part you can just use your debit card, but if you needed cash, or I needed to deposit the check by hand, right? What would I do? So, a person tried an experiment with 3 different banks and timed the wait times of all the lines in those 3 banks. They had 3 different people go into each bank. In Bank 1, they had an extra teller. All right, in Bank 1, they had an extra teller who only guided people by telling them where to go. So they just stood up there and said, here, you go there and you go there. They're ready for you. All 3 people in Bank 1 waited 6 minutes. So with that person doing that, they all waited 6 minutes, right? So 6, 6, 6, there you go. Anyway. Next up in Bank 2 was a typical bank where everyone just waits in a big long line. And they just say next, and the next person comes up, right? Well, one person leaves, everyone else moves up 1 spot, and the person that is up goes to the next available teller. First person waited 4 minutes, then the other 2 waited 7 minutes, and right? So whatever, the first person made out like a champ, and the other ones had to wait a little bit longer. Bank 3 was like a grocery store. Picked your own line, and you walked right up. Right? Picked your own line, walked right up. The first person waited a minute, the third person waited 3 minutes, and the last person waited 14 minutes because they chose an awful line. They were probably behind one of those elderly people. Okay? So, looking at all 3 banks, maybe you luck out and you pick the right line on your own, or maybe we just kind of go to a nice average where I'm guaranteed that we all wait about 6 minutes. Now, you can find the mean of each, and I do. Find the mean of each, that's 6. Find the mean of each, that's 6. Find the mean of... They're all 6 minutes. So the average is telling me that regardless, on average, when I pop in there, I'll wait 6 minutes. On average. Do you see that if all we ever did was calculate the average or the mean, right? It's not really telling me how the data is shaped at all. It's not. This is way off. You're expecting to wait 6 minutes, but now I got in real quick. You're expected to wait 6 minutes, but now I'm waiting over double. Right? This one, oh yeah, it's dead on. Every time. Always 6 minutes. Bank 1 is totally uniform. No one ever waited longer than 6 minutes. Bank 2 was pretty fair, right? The times are pretty close to 6. That's fine. Bank 3, however, was way off. All right, way off. Some people waited almost 14 minutes. Which bank would you want to go to? Well, most people are going to say, not Bank 3. Right? Well, just in case it's me who's waiting 14 minutes. If all we did was the mean, right, we would miss the spread of our data. We would miss the variation of the data, how it varies. So, ways to find the measure of variation. One way is the range, right? Low to high. It's the highest minus the lowest that will tell you the range of values. That's what it's going to tell you. That's the easiest one that most kids already know. A sense of variation that you've been doing for a very long time. But what may be the downfall of the range? There could be an outlier. Again, Outlier could affect it. A really high or really low number that doesn't correlate to connect with the data at all. So it's going to skew off what the middle term actually is. The opposite could be said. If you have hundreds or thousands of data points all sandwiched around the same number, the range would be a very small distance between the two values, right? Very small. Range can be useful for small amounts of data, all right? Like the bank example I just did, but it will not take into account all the values. So then we have standard deviation, which is the one that many of you have heard this phrase or word before, but have no idea what it really is. This is the most important and most useful variation for us in this course. All right, standard deviation. Standard means average. Deviation means how it is separated from the average. It means how far it is separated. I have no idea what that means. How far it is separated. There you go. How far it separates from the average. So what it calculates is the average distance your data points are from your mean. All right. It calculates the average distance away from the mean, is what it does. Standard deviation measures the average distance your data values are from your mean. So fact 1, standard deviation is never negative. Okay? Never. Fact 2, it's also never 0, the standard deviation, unless all points or values are the same. Literally, the bank line. Every value is a 6 and a 6 and a 6. That means the standard deviation is 0, because they were all the same. Even if it's off by 1. If it was a 6, and a 7, there's no 0 in that standard deviation anymore. Standard deviation is greatly affected by outliers as well, okay, depending on how far the outlier is. And sample standard deviation is noted with a lowercase s. Population standard deviation is located with this sigma sign right here. Okay? So, how do you find the distance between 2 points? Okay? It's simple. You just subtract them, right? So, to find the distance from the mean, I would just do, right, what the mean is minus what the point you found is minus the sample mean, right? The distance between them. That's basically what that is. That point you found minus the mean would be the distance between them. However, some values will be too far left or right from the mean. For example, if my mean is 5 and I want to find the distance from 7, I would do 7 minus 5, which is 2. But if I wanted to find the distance from 3, it would be 3 minus 5, which is negative 2. But technically it's the same distance, it's just in a negative direction. And I said standard deviation can't be negative, so if I square those, it will always be positive then, right? Any number inside when you square it is positive. So if I take those and square it, now if we do this, it will explode, as in like our outlier is going to get huge and make it really far out there, right? If I'm squaring something, it's going to make it way out there. So, but this is one term to the mean. All I need, all right, are values in terms in my set from the mean, so I add up each individual one. So I need the sum of all of those. And to find the average, I need to divide by the number of data in a sample. All right, well, sample's n, population is a capital one, so, but I'm actually going to be using n minus 1 here, and we'll come back to that. I'm going to stop the video right here, and when we come back, we'll finish up with finding the standard deviation, but that is your basic formula currently for finding standard deviation, or at least the start. This is the start of finding it.